Okay, and we have no more talks today. And now we have the Q&A session, the general Q&A session with our VP of software platforms, Eva. So now I'd like to invite Eva to join us. Hey, Eva, how are you?
Hi, Peter. Still good. Very happy about the conference.
Yeah, so we have a couple of questions here. So we picked some of the questions during the day, and now we will try to answer all of them. So let's start for the first one here. So ESP32C5 dual band Wi-Fi was announced last June, but nothing visible has happened about since then. When can we get specs, or when can we get chips?
So C5 at the moment is internally available in Espressif in the form of engineering samples. We don't have the fixed date of mass production yet, but my best guess at the moment is that we will have the engineering samples available to our customers in around April next year. You can contact sales at espressif.com in the meantime, and they will put you in the queue to get the samples when they become available.
Okay, one more question about new chips. Found some ESP32C6 supported in IDF 5.1 dev, but cannot find any data sheet of ESP32C6. When will the ESP32C6 release?
For C6, the timeline is a bit more clear at the moment. I think we will be able to ship samples to customers in Q1 next year. So same as for C5, please do contact sales at espressif.com if you're interested, and they will put you in the queue.
Okay. Next question. Are the C++20 features that would not be supported, like coroutines, file systems?
Yes. So for C++20, I think coroutines can be used at the moment to the extent that you can find a library that implements them. I think some of our colleagues are working on the ASIO library port for ESP-IDF, and as far as I know, coroutines do work there. As for C++ file system library, yes, this is indeed not supported yet. There are a few limitations in how we integrate our virtual file system, so we will resolve this, but probably definitely not in 5.0. Might be 5.1 or one of the later releases. Aside from that, I think all the features that are supported by GCC in GCC 11 at the moment, they will work. Keep in mind that GCC 11 does not implement all C++20 features.
Okay. Next is not a question, but we have some feedback for you. So ESP32DE said your WASP3 example works like a charm in IDF 5.1. Few things must be reheaded, retyped. Thanks for the example.
Oh yeah, happy that you found it. This was an example that I did for one of our internal hands-ons workshops here at Espressif, just to demonstrate WebAssembly on embedded devices to our colleagues. I haven't updated the example for 5.0, 5.1, so it's a good reminder. And generally, I think WebAssembly is a pretty interesting technology. We are kind of always on the look of how to use it, how to deploy it in embedded devices, but the capabilities for isolation and also being able to compile from many different languages into WebAssembly, that's really cool. Yeah, it's an interesting space to watch.
Nice. Okay, next one. Will ESP Modbus utilize Modbus TCP or Modbus RTU or both?
Both. The library is the same as the free Modbus library in IDF 4.4 with some improvements that have been done since. So it supports both TCP and RTU and server and client, or master and slave.
Okay. Next question. Is there a good TOF time of flight example for the ESPS3? Also, is it just Wi-Fi TOF or can be used with other sources? Example like emitter, sensor, so functions like high resolution timer and ADC?
There is a Wi-Fi time of flight example in ESP-IDF. You can find it under examples Wi-Fi FTM. FTM stands for Fine Time Measurement, and that's the kind of official name of this feature. Maybe even Pedro knows more about FTM than I do, because I remember that you, Pedro, did some experiments with it. So yeah, take a look at the README of that example. It does explain how to set up the responder and initiator, and then you can flash to development boards. This feature is supported from ESP32S2 and later. As for other protocols or like physical connectivity, I think this is not going to work with Wi-Fi because Wi-Fi uses very specific hardware. If you have some time scale that is on this on the range of times that can be measured at the APB clock of Espressif chip, like 80 megahertz typically, then you can use something like an RMT peripheral. So for example, you can set up one RMT channel to generate just a very narrow pulse, sort of one sample at 80 megahertz, and then use another RMT channel as receiving channel, where you will receive both the generated pulse and the response, and then you can use RMT to measure. So the resolution in this case will be whatever is one cycle at 80 megahertz, 12.5 nanoseconds.
Okay, so next, very nice updates. If I'm using Arduino IDE, do I get the new features of IDF?
Yeah, I think this was a question after the talk about IDF 5.0. The answer at the moment is no, you don't yet. Arduino IDE, the Espressif Arduino core is currently using the version 4.4.x, 4.4.2 at the moment. There is a plan to upgrade the IDF version used in Arduino core to something more recent, and I think at the moment the plan is to upgrade directly to 5.1 when 5.1 is going to be released. So sometime in the future, there will probably be a branch on Arduino ESP32 GitHub repository, which will allow using IDF master branch. And eventually we will try to converge so that by the time that IDF 5.1 releases, Arduino ESP32 core will also support the 5.1 release. So you'll have to wait a bit.
Okay. Next one. Do you think you will switch ESP IDF to C++ in the future?
Yeah, this is a question that I think was raised after Jacob's talk about C++. C++ brings a lot of nice features, and it can help reduce the chance of making some mistakes that are common in C projects. However, at the moment, we probably will not switch to C++ because there are still quite a lot of projects where developers write C code, and using C++ code from C would require creating wrappers, essentially the same as our C APIs right now. And that means that losing a lot of those safety guarantees that you can get from C++ if you use different good practices in designing C++ APIs. So effectively, we would still have to provide the same C APIs as we do right now to satisfy the needs of some of our users, and yeah, plus work on C++. So we decided to approach the problem in the other way at the moment. So we will have the C-based SDK, and then the C++ will be C++ classes will be provided as a separate repository that will be wrapping the C APIs. So yeah, that's what I can tell so far about C and C++.
Okay. So last one, unrelated to this specific talk, but does anyone know when chips switched from the default date of January 8th, 2013 to January 8th, 2016, and then July 9th, 2019?
Oh, yeah, those dates I know really well. So the dates actually, to give some context, those are the dates that are printed on UART when you reset the ESP chip. So if you take an ESP8266, it will print January 18, 2013. And if you take an ESP32, then it will print June 8, 2016. But if you take a slightly newer ESP32, then it will print July 9, 2019. And essentially, it's just the timestamp or date stamp when the ROM code inside the ESP chip has been compiled. So ESP8266 ROM code was compiled in some January 2013, and then for the ESP32 we compiled the final ROM code in June 2016, and then we had ESP32 EC03 revision 3, which contained some security fixes and generally some improvements. And then we had to compile the ROM code again, and that was in July 9, 2019. And other chips, like for example ESP32 S2, it will have some other date, like I don't know, some date in autumn 2019, I suppose.
Okay, so now I'd like to know if you have any other question, like from your side to be answered. I'm not sure if you have some or anything that you'd like to share with us. So
I'm looking at the YouTube chat right now and seeing if there have been any other questions posted recently. There is a question about what about ESP32H2? Is mass production already happening? I think this was answered yesterday in the general Q&A by MA. So H2 samples will be available, I think, in Q2 or end of Q1, early Q2 next year. So yeah, basically slightly after the C6. And same thing that I said about C6 and C5 apply. You can contact sales@espressif.com and they will put you in the queue for getting the samples when they become available. And another one I see in the chat.
Sure,
oh yeah, go ahead, Pedro.
Yep. So one from Uri. When a developer should choose OS for ESP32, there are options like ESP IDF, or Zephyr. Are there specific use cases when one of these systems is better?
Yeah, there are probably several things that you need to consider. We have a blog post on Espressif website about support of third-party operating systems, Zephyr and Nutanix, and the answer is to some extent given there. Very briefly, you probably would want to choose Nutanix if you're interested in a POSIX compatible operating system. So Nutanix is probably the closest out of three compared to Linux. So if you have some Linux-based code already and you would like to have the sort of gentle migration into embedded space, so if you want to use same programming model as you would use on Linux, then probably Nutanix is the right choice. Zephyr is supported by a lot of other, or rather Zephyr supports a lot of other hardware from other manufacturers. So if you have projects which need to target different chips, or you already have some code base that has been written for other microcontrollers on Zephyr, or you have multiple chips in your design, or maybe you have multiple products and Zephyr covers all the chips, then Zephyr is a really good choice. As for ESP-IDF, choosing ESP-IDF probably if you're interested in getting the fastest updates from Espressif. So if you need quick support, then we will be able to provide that for ESP-IDF better than for other frameworks at the moment. Also, ESP-IDF is primarily optimized at IoT applications. So if you're building something IoT related, then you will find that ESP-IDF plus the components around it, they kind of come with all batteries included. So we believe that if you want to build a production application, then you will primarily need to only write your business logic, and all the other features, the cloud connectivity, over-the-air updates, diagnostics, everything will be provided for you.
Okay, not sure if it was this question you tried to mention, but not sure if you have.
Yeah, that is the blog post.
Yeah. So Sergio, he shared the blog post. I think it's this one. Okay, so I think we have here a question about the S3 with the LX7 is very interesting, but the RAM is still small. Can you increase it in a new chip?
Yeah, we have some devices in our pipeline that probably will have more RAM than S3. So far, what I can say is that S3 luckily supports PS RAM, so you can connect quite a lot of, I think, up to 32 megabytes of PS RAM to an ESP32 S3, and for a lot of applications, PS RAM can be fast enough, especially if you use octal PS RAM and run it at higher frequency. Generally, putting more RAM on the chip is possible, but it makes the chip more expensive. And to be able to justify making a new product, we also need to make sure that we will be able to sell it in sufficient quantities. So that's kind of one of the limiting factors here. So for some products, it will definitely make sense to have more RAM, and when we have a right use case, we will increase the amount.
Okay, thank you. So I think we have no more time for questions, but we will try to answer right on the chat. So I'd like to thank you for this special Q&A session. Yeah, so thank you.
Thanks, everyone.